All right, let's dive into something that really sounds like it's straight out of science fiction, but is actually reshaping our reality as we speak. We're talking about quantum computing. It's a technology that promises to solve problems we once thought were impossible, and maybe even break things we thought were unbreakable.
So just think about this for a second. Picture a problem so ridiculously complex that even our fastest supercomputers today would need, thousands of years to figure it out. Now, what if you had a completely new kind of computer that could look at every single possible answer all at the same time? You can see this isn't just a little speed boost, it's a totally different way of computing.
And then there's the other side of the coin. Think about our digital world. Everything from your bank account to top secret government data is protected by encryption. And that encryption relies on math problems that are just too hard for normal computers to solve. But what happens when a machine comes along that can solve those unbreakable codes like they're a simple crossword puzzle? The implications there are just staggering.
And let's be super clear here. We're not talking about some far-off future concept. These machines exist right now. Now, they don't look like your laptop. They're more like these incredibly complex, beautiful scientific instruments. And right now, companies and countries all over the world are in a massive race to build bigger and better ones, pushing the absolute limits of what we thought was possible.
So, how in the world do they work? Well, the first thing you've got to understand is that a quantum computer isn't just a souped-up version of what's on your desk. It plays by a completely different set of rules, a whole new logic that's borrowed from the bizarre, fascinating world of quantum mechanics. This right here is probably the best way to get your head around the basic difference. Classical computers, the ones we use every day, they run on bits. Just think of a simple light switch. It's either on, which is a 1, or it's off, a 0. That's it. But a quantum computer, it uses something called a qubit, and a qubit is so much cooler. It's like a dimmer switch. It can be all the way on, all the way off, or, and here's the crazy part, it can be in a mix of both states at the exact same time. And that dimmer switch idea, that ability to be multiple things at once, that's where all the magic comes from. So let's peek under the hood a little bit and look at the quantum ideas that make this whole thing work. And don't worry, you won't need a degree in physics for this. Okay, first up is this idea called superposition. The best analogy is a spinning coin, right? While that coin is spinning in the air before it lands, is it heads or tails? Well, it's kind of both. It's in a state of all possibilities. That is exactly what a qubit does. It holds the potential of being both a 0 and a 1 simultaneously, and that's what lets it explore this huge number of possibilities all at once. But superposition is only part of the story. Qubits also have this other spooky property called entanglement. You can link two qubits together in this special way, and from that moment on, they're connected. If you measure one, you instantly know the state of the other, even if it's on the other side of the galaxy. It's wild. And then engineers use something called quantum interference. Think of it like noise-canceling headphones for a calculation. It's a clever way to make the signals for the wrong answers cancel each other out, which makes the signal for the right answer stand out. It's how the computer finds the solution in all that noise.
So, what do you get when you mix together superposition, entanglement, and interference? Well, you get a machine with the power to go after problems that are, for all intents and purposes, completely impossible for any supercomputer we have today.
And here's where it gets truly mind-bending. The exponential power. With a regular computer, if you add another bit, you get a little more power. It's linear. But with a quantum computer, every time you add just one more stable qubit, you literally double its computational space. So 2 qubits can explore 4 states. 3 qubits can explore 8. If you can get to just 300 qubits, you could process more states than there are atoms in the entire observable universe. It's just a staggering leap in power.
And this slide shows you exactly why anyone should care about that kind of power. We could simulate molecules with perfect accuracy to discover new drugs and vaccines in a fraction of the time. We could design revolutionary materials from the atom up, like better batteries or maybe even room temperature superconductors. In finance, you could solve optimization problems that are just beyond us today. And yeah, that cybersecurity threat we mentioned, it's real. A powerful enough quantum computer could theoretically break the encryption that protects almost everything online. This all sounds incredible, almost unbelievable. But where are we right now, really? Let's take a breath and get our feet back on the ground, because building these machines is, without a doubt, one of the greatest engineering challenges humans have ever faced. First, a really important reality check. A quantum computer is not going to replace your laptop for checking email or scrolling through social media. They are highly specialized machines. They're like a Formula One car,
unbelievably powerful for a very specific job, but you wouldn't use one to go get groceries. They're a tool for a specific set of problems.
And building them is just incredibly difficult. Qubits are unbelievably fragile. The tiniest vibration, the smallest change in temperature, can make them lose their special quantum state. It's a process called decoherence. This means they make a lot of errors, and figuring out how to correct for those errors is a massive, massive challenge. On top of all that, most of these systems have to be kept in ridiculously controlled environments, often chilled to temperatures literally colder than deep space.
But even with all those hurdles, the momentum here is just undeniable. And I think this quote really says it all. We are standing at the very, very beginning of a technological revolution that could be just as transformative for our century as the classical computer was for the last one.
So it leaves us with this huge question, doesn't it? We're on the verge of having this power to perfectly simulate nature, to break any code, to solve the unsolvable. Will this technology become humanity's greatest tool, pushing forward medicine and science in ways we can't even imagine? Or will the challenges, especially around security and ethics, prove to be one of our greatest tests? The quantum age is here, and we're the ones who are going to have to figure out the answer.